On July 24, 2026, Starship Flight 13 ended with a sight SpaceX had been chasing for years. The upper stage upright over the Indian Ocean, completing its landing burn and touching down intact. This was not an operational mission. It was a suborbital test of version 3. A new generation of the 124-meter rocket designed to make both stages recoverable and reusable. At the bottom is super heavy, powered by 33 methane-fueled Raptor 3 engines. Above it sits Starship, with 3 sea-level Raptors and 3 vacuum engines optimized for the climb through space together. They form the most powerful launch vehicle ever developed. SpaceX says a fully reusable Starship is intended to carry more than 100 metric tons to orbit. But that capability still must be demonstrated. Flight 13 began at Starbase. Texas 33 booster engines ignited beneath the launch mount, producing a brilliant plume as the stainless steel stack accelerated through maximum aerodynamic pressure around 2.5 minutes after launch. Starship ignited its engines while still attached to the booster. Heavy then flipped and started its boost back burn. For the first time on a version 3 booster, all 33 engines completed the high thrust portion, sending the stage toward its offshore landing zone, but the landing was imperfect. Not every planned engine returned for the final burn, and Super Heavy struck the Gulf harder than intended. Starship had advanced, but booster recovery still needed work. Meanwhile, the ship continued onto its planned suborbital trajectory. It opened its payload bay and released 20 Starlink V3 satellites, the first production payloads deployed by a Starship test vehicle, because the mission was suborbital. Those satellites were not intended to remain in space. Their short flight-tested deployment, communications, and hardware behavior before atmospheric reentry. Starship also restarted a Raptor engine in space. It may look routine, but reliable restarts are essential for changing orbit, controlling. Returning from space converts enormous speed into heat. Thousands of black thermal protection tiles shield one side of Starship, while 4 movable flaps guide it through the atmosphere. During Flight 13, the ship transmitted data through the fiery descent and remained controllable. Every tile, joint, flap, engine line, and software command was being tested under real hypersonic conditions near the ocean. Starship fell almost sideways, using drag to slow down. Seconds before contact, 3 sea-level Raptors ignited. The vehicle flipped vertically, reduced engine count, and settled onto the water. The ship stayed intact after splashdown. That matters because rapid reuse requires more than surviving once. A vehicle must return with limited damage, be inspected quickly, refueled, safely flown again. SpaceX wants launch towers to catch returning stages with mechanical arms, removing landing legs and accelerating turnaround. Earlier tests caught. NASA is developing a Starship-based human landing system to transport astronauts between lunar orbit and the moon's surface during the Artemis campaign. The current plan has changed. In 2027, an uncrewed version 3 Starship test article is expected to dock nose-to-nose with Orion in low Earth orbit. Artemis astronauts will remain. Inside Orion, NASA now targets 2028 for a later crewed lunar landing. Reliable docking, long-duration operations, and an uncrewed lunar landing. Flight 13 did not prove that Starship is finished. It proved the design is learning. The next breakthroughs must be repeatable. Safer, booster recovery, durable heat shielding, orbital refueling, and true rapid reuse.